So this is the second lecture of this week, and where we are talking about the logistic regression and adjusted odds ratio. And in this part two, I'm going to be discuss about how you want to be see the difference between the odd ratios, like we have uh, discussed how we calculate this odd ratio in the last column, and then the reference category and how those the odd ratios will be consulted with respect to the reference category. So now these calculations are independent from each other, which is just a simple mathematically I demonstrate. But when we will be using a multivariate analysis, so we have a more than one variable as the independent variable. So we will see the combined impact, and we want to be estimates the the variable impact odd ratios by controlling the others. So the odd ratios can be adjusted for multiple factors, and in a multivariable logistic regression model, and the adjusted odd ratios provides a better estimate by controlling the confounding variables. So in other words, accounts for the influence of other variables in the model. And adjusting for wealth level, for example, if we control for wealth level in our regression model, the adjusted odd ratios might change for the other variables like when we discuss about it. So interpretation is after adjusting for wealth level, rural households are still less likely to have access to improved water compared to the urban households, which is adjusted odd ratio is zero point 0.5, which is a different. However, the factor of is smaller than the unadjusted odd ratio, which is a 0.18. So that indicates the part of the initial reference was due to a difference in the wealth levels. So this is the main difference you want to see and how you want to see in that calculation. So when you will be considering these variables as a confounding variable, so then you rerun that. That's basically why we use SPSS. They will give us those estimates, so we can easily do those kind of regression analysis. So now these values, you can see the change because of by controlling the wealth, and when we're controlling this area, so these informations, the odd ratios are adjusted accordingly. So that's we are going to see in SPSS in the next slides. Okay, so into the SPSS, there are few things which we want to be recall. Our focus is access to improved water sources. Data set is the Balochistan, Pakistan, and the 2019-20 data. Questionnaire, we dealing with the number of questionnaire in that survey. So we have using household level survey data, and in SPSS file, they're basically named at hh.sav file, and the dependent variable which we created by using this ws1 variable. They have a number of categories. We group them into two sources, improved and unsources, which we already discussed, and then we have selected a number of independent variables, including sex of the head of the household, education, and wealth index quintile. And then geographically we have three different options, so we were trying to be area and the districts in this analysis. Let's go start in SPSS. So I believe you guys are familiar with this data set, which we are using for the previous recordings. So I'm just giving you a quick overview. Again, this is the file which I'm using in the household level data of one of the province in Pakistan. And we are focused on the drinking water sources, which is the question, which is number is WS1, and that question had the multiple options. So we regrouped them and converted into a binary variable, and the focus is the households have access to improved drinking water. So that is the main thing which we are trying to be see. So now the variable we will discuss in the previous slide, regarding the like different potential independent variables, predictors, which can explain the household who have access to the improved drinking water or household which not have. So there are different things which we can consider. So first, before running that, we know that we need to check the select cases. We have only the one which is we needed based on the variable called results of household interview. And the second thing is we need to set the weight. So we have the household sample weight. So we want to be enable it. So these two things are there. So you are going to be have a weighted sampling, weighted estimates. Okay, so now the for the regression, we have this binary logistic option in SPSS, and that will help us to set the dependent variable. So this is the variable which we prepared is a binary variable. So we have a group of household have access to improved water sources or not have access to the improved water sources. So that is going to be set as the dependent variable. And now these are the different variables we picked. I'm going back to those variables. So let's try one by one. So at the end, we have usually the few variables which we can use. Like as we discussed, we have a gender of the head of the household. That could be, we can see whether it's have some impact, influence. Then we have a education of the head of the household. That is another potential. And then we need to know the income wealth index which this household fall in. So this is the three variables we picked, and then we have another variable which we, if we were looking more geographical point of view, which we option I mentioned, there are three different options. So we can pick as a district, and then we can also see the area, which is normally in this case is located at the beginning of this questionnaire or the data. Okay, so now we have five variables which we definitely we when we run that cross tabulations and chi-square test, we know there are some associations and those kind of things. Just so we can also double check those kind of things if you want. And then we want to be setting the second thing is the category, because these all variables are categorical variables. So we need to set the categories for them. So for that, when you will be going to see it, it will be showing you like by adding those variables in the block. So they will be on the left side of this, and then you need to select all of them and move to the next like section, which is normally they decide the categories. So now here we need to be carefully select the reference category. So reference category, we have two choices, either first or the last in the list of the category. If you recall, when we have wind index, wealth index, so that index will start with the poorest to the richest. So if we take the first category, so poorest will set as a reference, and rich will be the rich, and other categories will be comparing with respect to that. Okay, so we're going to be set at the lowest one, and then in this case is HH6, which is area. Like first category, I believe is urban. So then we're going to be, let's try with the other way around. So we will take the second last option as a reference. Gender, we will pick randomly. Maybe either male is the first and female second. I don't know the code, don't remember the coding for that. So this is based on the coding, is not the actual label. And then we have HH7, I think is education, I believe so. Yeah. So now it's taking education means we have the first will be the no education or pre-primary or then primary. So it's basically we can use the first one, and then the levels. Yeah, so one of them is okay. So HH7 is the districts. So we're taking the first district as a reference, and then we have HH level is the education. So these are the categories we need to select the reference category. We will see in the results what I mean for the why we need to choose this first or last, and what other options we have. Okay, anyway, to continue this one, so you have a dependent variable, and now you set the those potential indicator predictors you want to be using it. At this moment, we don't need to set any other options. We do have some options. We might need a confidence interval for odd ratio. So let's try this one. And yeah, rest of the things we don't need to change anything else. So this is the way first we have, and then the method. We have a different kind of methods to include, but we will take the enter at this moment. But you can discuss or you can choose any other if you have a logic to build your model. Okay, let's try to see the results. Okay, so now we have a first table, which is an important thing which you need to be considered is called categorical variables coding. This is the most important table which we need to be concerned. We will come back to this table. And the second thing what we're looking is basically our zero model is there, zero step, and then we have a model summary. So this model summary is explaining you is a 48.5% of this variable explain the dependent variable, like you can explain with the help of those independent variable whether the households why not have like have improved access to improved water sources or access to the unimproved water sources. So those kind of things can be explained. So this number is very good. So 48% our scale values are very good. Considered as a good model summary. And then we need to be consider the table, which is the most important table, is the variable in the equation. So this is the table which you basically reporting in your manuscript. So that's the table which we're going to be discussed in the how to read that tables and what is the meaning of these kind of things. We have it. Okay, so let's try to rerun this regression again. And I'm going to remove this one of the variable for time being and just rerun it. So now we have this coding table because of the number of districts, its table was too big. So just want to explain you what is the meaning of this coding table is, and then how this table will help us to interpret these variables in the equation table, which is our main table, which we want to be discussing in the paper. Okay, so if you look at the wealth index quantile, we have a five options here. So with the no number, and then we have 1 to 4 numbers with the same variable name. First category is our reference category. And now you want to know next four categories, what are those actually are. So let's go back to this variable. So this variable is telling us variable in coding. So this table is giving you the wealth index quantile. So poorest is the first category, as you know we have set the reference, and here is the evidence. And when you see in all the next rows, so they have no number. So if they are set as a reference, so there will be no number like one. There will be all zeros, and when they set the as a variable to compare with the reference category. So they will have a number one. So then you will see the second category will be have one, third will be two, one as well. So they all has one, but in a different columns. So that's the way they assign this number to the wealth index quantile in one, two, three, four. So we know the four is the one, and that is the richest. So this is a way we will know about this table. So this is the one, if you see, is the reference category, which is poorest, second, middle, fourth, and then this is the richest one. So when you will export this table into the Excel, and we need to rename them before using into in the main document. So that's one of the reason you need to be understand how to first make the minor changes in this table and before start the interpretation of that table. Okay, so now that's the first thing we do, and then we have to do the similar kind of things with all the other variables when we're going to be interpret this variable. Okay, and then the next important thing which we need to look at the two columns, which is significant and is odd ratio. If you remember, we discussed about this column is actually exponential b is basically the odd ratio. We're going to be we need that information. And then all less than 0.05, it means these categories are important to consider in the model. And now with the respect to the reference, which is a 1, so 1.8 is the next category. And then if you see those wealth index quantile with respect to the richest group where the household belong to. So they have over 200 times more odds when compared to the reference category, which is the poor. So you can see the having access to improved water sources, how many odds you will be increased if you go to the next quantile and next and next. That information is important, and the significance telling you this is information you can include in the model. Okay, and then the last two columns basically giving you the lower and upper limit of this odd ratio. And this odd ratio is basically the adjusted odd ratio because it's compared with that with respect to the by controlling the other variables. So I can give you another example for example, what does this mean? I can remove one more variable and see these numbers, how these number will change. Let's go repeat this logistic regression, and we're going to be remove the first one, gender of education levels, okay, and even gender too. Let's go to the, so now we rerun this regression and see the values will be, how the values will be affected. So if you look at that, now the richest odd ratio, adjusted odd ratio is lower, 162, as compared to the poorest one, when we have only two variables in the model, which is the urban and rural area, and then we have wealth index. Okay, but before that, if you scrolling up and you see, this was 208, so that there was more, like consider like they have more odds when we having a four different more than two variables. I think it's a four variable or five variables. We four variables, it is value is 208. And when we remove the two variables, then only keep the two remaining two, and to rerun that model, and you see those values will be you see the improvement in those values. So that is the meaning is how many variables you include. So the estimation of the odd ratios will be adjusted according to the like the confounding factors of the other variables. So that's the main thing you need to be also consider when you were running the model. These values will be changed based on the number of variables you include into the model. Okay, let's go back to our original model where we have all those variables in the beginning. So we have a big list of the coding. So now, because we are trying to have a more contextual factors, and we want to use like mapping kind of options. So we want to see more geographical distribution. So districts are the ideal where we have like a number of regions which we can see the variations on the map, and there are over 30 districts in that province, and we have the estimate for all of them. So that's why the first table, if you see, this is a big table, and they will giving you all the numbers. So we have a 31 actually, and then will be the first one will be the one is the reference, so 32 districts in other words. So we have a 32 districts, and the first district is basically, if you see, is having no indication of one. So it's set as a reference category, and the rest of the districts will be um, interpreted according to this. So now, sometimes you want to pick your own district as a reference, and you want to be rearrange everything accordingly. Okay, so there are some ways to do that. So by default, we have only two options. Either we can choose the first category based on the coding list, or the last category again based on the list of the coding we have in that variable. So that is the limitation at this moment, but there is some way to change the coding And then if you change the coding and bring the district which you want to be set as the first district to set as a reference category, we can do that. So we will definitely try to see which district we need to be considered as a reference category. Sometimes you want to be the district which has the lowest improved water access ratio, and then some you want to see at the middle, or some district you want to see that's okay, this is district has a most important information. We think like other districts with respect to that, it makes some sense when we will explaining this result to some policymakers and decision makers, if they're reading that one, so they can understand. So for example, the Koita is the provincial district headquarter. So if you want to be discuss about with respect to the Koita, so that could be a meaningful, like how the other districts had advantage and disadvantage with respect to the access to the improved drinking water sources. So that could be another strategy you want to see it. So before going to making those table into the manuscript point of view, we need to be develop that strategy, how we going to be interpret. The same thing will happen with the other categories. So if you're thinking like the poorest, you want to compare with the rest of the poorest group with respect to the other, or you want to see the middle group and above and below, and then those kind of things. So this could be another strategy. And sometimes you want to be group the categories, some like for in this case like pre-primary or primary, if you want to be consider them together, so we can combine them, or we will want to see the disadvantage or advantage with respect to the other categories, we can also consider that same thing. So here we have comparison when you want to see with respect to the urban rural. So when we have only two categories, so then we have easy to choose which one is based on the first and last. So right now we have a rural category as a reference, urban is with respect to that, and then we have a male as a reference and female is a the group we want to be compare when we were looking at the results. So this is the way you want to be reconsider the coding mechanism, and if you want to be planning to make some more meaningful infographics or diagnostics or estimates based on that. So you see there are a lot of options, the things which you need to be considered. And let's try to see the change in the model summary. So when you have all five variables in that model, including the district one, so we have R square values is 0.485, which is 48.5% of the model variance. And then if you go to the next, uh, our model which we run, and we have changed those variables. This time we have only two variables in this case. So these two variables, based on that, our model summary is basically is 25.9. So now we're only two. If we include only two, so we will be having a like less explain the dependent variable, and then if you include more, so we have more power to explain the variability in the dependent variable. Okay, so now the last model which we have, that one, let's see how many variables we were so yeah, so this is a two variable model, and yeah, so the last one is here, and this one is, yeah, it's a slightly change, but there's no big change in that variable as well. So you can see by adding the variables in predictors, they can change the model summary, give you the better model fit, and which we normally we use. We want to be have a better model predict, like model better fit as well. And the same thing is when we will discuss about this. Variables in the equation, we need to report other like those model summary as well in that. So we will discuss about these kind of things, how we will report that results, how we will be taking that one into our manuscript, and how we will make those maps if we have to be developed. So those kind of things I'm going to be discussed with in the next lecture, we will explaining all those things how we want to do it. So we will develop some strategies by recoding process. So if you are thinking like some district and we need to set as a reference category, I'm also going to be think about it, and you need to be see if you have any suggestion about that. So I believe you are running this if you are up to this point and at this lecture, so I think you have some data set with you, you're following those steps and running those one. So now you we need to be discuss about our research question and how this logistic regression is going to be helpful to achieve those objectives. And now we want to make it more meaningful, because if you just want to recall remind you, so the purpose here is to take this data and make the manuscript and publish it. So now we learn all those basic things up to the regression. We understand the data sets, and we have conceptualized a research objective which is a publishable. And in this case, I'm going to be working on a paper like in that province, how the households have access to improved water sources or not, and then those kind of things we will discuss about in the two things like income levels also important, some head of the household information, household level information, and more important thing is the geographical contextual factors. We're looking the urban and rural urban and versus rural, and then we also looking the distribution of those across more local levels at the district level, which other words we're talking. So we have a lot of things to include in the paper, and we can discuss it, but now we have to make it more logical, and that's we are going to be discussed in a logical way. We will rerun that regression again, and then we take that results into like how you will prepare that result in Excel, and then we will moving that into the Word document. So you start like documenting those things and preparing your manuscript. So this is the whole plan. I just want to make sure you are following those things in a right way, and you have your data sets, you understand it now, and now we are going into those variables and dealing with the different coding, so we can have the results according to our expectation as per our plan. Thank you for thank you for watching this video, and hopefully we will have a very interesting session next week where we will learn how we'll be moving this information from SPSS back to our write-up stuff. Thank you.